Hello everyone. In this video, I will demonstrate how to configure S7200 Smart PLC as Modbus Slave using onboard RS485 port. This type of communication is useful to share data with third-party devices like DCS, PLC or HMI for monitoring purpose. Before we begin, if you find this video helpful to you, don't forget to hit like button and subscribe to our channel. You can also join us to get access of members-only videos. Or show your support us by sending super thanks to us. The pin configuration for connecting RS485 cable on 9-pin connector of the PLC. You need to use pin number 3 and 8 for data and pin number 1 for shield. Let's start configuring the PLC. Here I am using ST20 CPU. And IP address of the PLC is 192.168.0.1. Here, first I will configure the blocks to make PLC as Modbus Slave, and then we'll test PLC's digital input, digital output and internal V memory on Modbus Tester. Modbus Tester will act as a Modbus Master. Now from the Libraries folder, locate Modbus RTU Slave Library, and select the MBUS INIT block. This block will initialize the settings for Modbus communication. Note that, this block is required to call only once. You can use first scan bit of the PLC at the enable N input. In that case you will be required to restart the PLC. Here for demonstration I am using M0.0 and will trigger it manually. Let us first understand all these parameters. In mode set 1 for Modbus and 0 for PPI communication. Here it will be 1. Address is the slave address of this device. Here I will set it to 3. But you can set it as per requirement. Set baud rate in baud parameter. Here I will set it 9600. In parity set 0 for no parity, 1 for odd parity and 2 for even parity. Here I will set it 0 for no parity. In port, set 0 for CPU on board port and 1 for signal board. Here I am using CPU port, so it will be 0. Delay is for timeout. We'll set it 0. Max IQ is number of input, I, and output, Q, on the Modbus. Setting 0 will disable the digital input and output read-write. Here I will set max IQ equals 12. Max AI is the number of word input, AI, on the Modbus. Setting 0 will disable the input reading. As I don't have any analog card with me, I will set this as 0. In max hold, set the number of word. This will avail V memory on Modbus holding register. Here for demonstration I am setting max hold equals 20. And configuring tags for done bit and error byte. Now we require to call one more block called MBUS SLAVE. This block is required to call continuous basis. So here at enable will be always true. And also configuring its done bit and error byte. We require to assign memory for this block, for its internal working. For this, right-click on the program block and select library memory. Suggest address will check for first available free memory and it will use 781 bytes. So make sure it is not overlapping with your existing logic. Here for example I am not using any memory V500 onwards, so I will set start address as VB500. Now let us compile the logic and check in the cross-reference. that memory starting from VB500 onwards is showing in use. This memory will be used by Modbus Slave block. Now let us download the blocks, and then we will check on Modbus tester. Program is downloaded successfully. Now placing the CPU in run mode. Let us monitor the blocks. Go to debug and click program status. Now, as I said earlier, we required to call mbinit block just once. I will first turn this tag on, and then will turn it off again. Note that here you can use the first scan bit, but in that case, you will be required to restart the CPU. Now we will check Modbus data on Modscan software, which acts as a Modbus master. I am using USB to RS485 converter. And COM port number can be checked from device manager. So here my COM port number is 2. Stating the Modscan software, and setting the parameter as we have set in the ST20 CPU. Device ID is 3. Baud rate is 9600, and parity is none. Click OK and it will start communicating with PLC. You can notice here for every poll, we are getting valid response from the slave device. Now let us modify some value and check in the Modscan. Holding register is starting from VW100. Put some addresses in status chart and change the value. You can notice that same values are updated on Modscan as well. You can also write values from Modscan, and same will be updated on PLC. Now let us check some digital input of the PLC. This will come on input status of the Modscan. I will give 24 volts DC to the channel, and same will be updated on status chart of the PLC and input status of the Modscan software. Now let us write digital output of the PLC from Modscan. This status will come on coil status of the Modscan software. If I change value from the Modscan, it will turn on the digital output of the PLC. So, before providing digital input and output access on the Modbus, make sure about safety system of your machine. Now let us try to read addresses which we have not configured in the Modbus block and see what happens. As we have configured 20 addresses on holding register, we can read 20 addresses on Modscan without any problem. But if we try to read more than 20 address, there will be no response from the partner. This case may happen when Modbus master like DCS or other PLC sends query on address which are not exist on your PLC, then they will not get any response. And you keep doubting on your PLC program. So in such case, always read and verify data on Modscan software. So friends, I hope this video was helpful to you. Please don't forget to hit like button and subscribe to my channel for upcoming videos. Thank you for watching and see you in next video.